Recently, I've spent a lot of time researching what Mike at Sea and Land would call wire organization porn. This week, I got to apply some of what I've learned to organize all the cables that are coming into what will become the switch panel cabinet. It was a really fun project, and especially for those of you that are into this subject, you will get a lot of satisfaction, or you might have a lot of critique about the way that I got to organize everything coming into that space. My name is Matt. Follow along as I turn Duracell, the legendary ocean racing sailboat, into a comfortable cruising home. All right, so we've gotten a ton of the wiring done, and this is where the breaker panel is going to be. And so a ton of the wires terminate in this area. As I've said before in episodes, one big disadvantage to building a boat out of fiberglass with a foam core is that it is really hard to mount stuff to the walls because screws will just pull out basically. And so I'm having to install mounting boards, and that's what I'm going to be working on today, is installing a couple of plywood mounting boards. These I just coated with epoxy, and I installed these little feet on them. And that is so that I can actually remove the board really easily if I want to. Anyway, I'm going to be mounting a board to each side, and I'm just going to be gluing them on with this. It's methyl methacrylate glue. So these are the little mounting pads that Mike Gerritsen at Sea and Land Yacht Works, he printed these out for me with his 3D printer. And these are kind of like the weldable studs, and I just put these 1/4 bolts through them, and they're held by the pad itself, and then I can glue the pad to the wall, and it holds the stud in place. They're very, very cool. Another little item that Mike is using to convince me to get my own 3D printer. I'm going to be mounting stuff like tracks and terminal blocks, bus bars to these two panels. So the next thing is I'm going to start installing tracks to try and visualize how all the cables are going to be run and everything. Yeah, this should be a very fun and satisfying project, especially when to see all the wires organized. All right, so I've figured out a basic plan for running the wiring inside this cabinet. What I'm going to do next is take this panel off, and we'll just set it on the table, and we'll build the wire runs on the countertop. So this first track is taking all the cables and distributing them to all the terminal blocks. So I'm going to tape this thing to the panel first. Then we'll go on from there. Now, like I said before, there are a bunch of wires coming into this cabinet, and what's really important to me is that they are really well organized, all well labeled, and it's a place for me to troubleshoot. And so I can quickly, if there's a problem, I can quickly open the panel, open the door to the cabinet, and put my multimeter on individual places that are labeled so I can start my troubleshooting here. That is the goal today, is to make a very organized panel for all these wires to run through and then onto the breaker panel, which will be on the face here. Not only will this cabinet hold this wire organization, but it will also hold more fuse blocks and computers like servos and other stuff that we'll get down to down the road. For now, what I'm working on is just this organization panel.
All right, now I have a few different pieces of equipment here that I'm going to be using to organize stuff. These are bus bars, and so this is for stuff like a common ground, so all of the grounding wires can come into one of these bars. And then I also have terminal blocks, and I have a couple different sizes of terminal blocks. These are actually coming from the breakers, and they will lead through these terminal blocks, and this is where I can do my troubleshooting from, putting the multimeter on these individual terminals. And so my main cable run is going to come up this side. All the cables together will come up this track, and then they'll branch off into the terminal blocks or the bus bars. So that's what I'm going to be working on this afternoon, is organizing this whole thing, measuring, futzing, making it look pretty.
It's important to me to be able to look at this panel and quickly find what I'm looking for. There are a lot of cables coming into this cabinet that need to be organized, so if I can break them up into individual legs that are organized by alternating and direct current, DC positive and negative, or the spaces or utilities that they're servicing, I'll be pretty happy. I went through a few different drafts placing where I wanted the bus bars versus the terminal blocks before I was happy with the organization. Once I had a plan in place, I found that the double-sided 3M VHB tape is really handy for sticking the components to the panel before screwing them down. I sent a picture of my plan to Mike for approval. He made sure that my AC ground bus bar is next to the DC negative bus bar because they'll be wired together. But once it was approved and everything was fastened down, it was time to get it installed.
All right, so I've got this panel laid out. I've got my terminal blocks, my bus bars, and all the tracks are all screwed onto it. This is going to be my organization for all the wires coming in. And so we're ready to install it, and then I can get to wiring. All right, that's one of about 200 of these things I got to do. Should be a fun project.
All the DC positive leads are labeled and screwed to the terminal block. On the other side of each terminal will be the leads that go to the switch panel and the breaker, which is the main distribution for the 24-volt direct current and alternating current circuits. These terminals are where I can put my multimeter to do any troubleshooting. I organized them by utility, so all the bilge pumps are in one section, all the electronics are in another. Lights will all go together, which will be organized into indoor and outdoor lighting and so on. This is one of the DC negative bus bars. All of the negative cables come to the same place, which then is fed back to the battery. I don't need to label these because they are all led to the common point. I have to use multiple bars which will be connected together. While the yellow DC negative leads have their own bus bar, the AC neutral and ground also have their own bus bars. There are not nearly as many AC circuits as DC, so I don't need as many connections. So these dual bus bars come in very handy for this situation. These two bus bars are not connected to each other, they're separate. The white is AC neutral and the green is the ground wire, which will be connected to the DC negative bus. And again, I'm incorporating a service loop into each lead in case I have to make any adjustments in the future.
So this is all wired in for the most part. Again, this is basically the main distribution for the 24-volt circuits and as well as the AC circuits in the boat. This is AC up here, there's more AC circuits down there. But there's also a bunch of secondary distribution, just like in previous episodes we've shown the fuse blocks for the lighting. So there's a bunch more of those little fuse blocks that need to go in for things like electronics and more lighting and fans and running lights, stuff like that. So I'm going to install a second panel on this side, and that is going to organize all that secondary distribution as well as hold some components like Victron servo boxes, which are kind of the brains behind all of the battery communication and relay stuff. Well, that's a whole long discussion later down the road, but this panel will hold more stuff like that. So I'm going to get to work on that next.
Again, using these racetracks is really helpful for visualizing wire runs, and then making edits to those wire runs is really easy. The racetracks surround the components like bus bars and fuse blocks to feed the individual leads very cleanly and clearly. I spend probably too much time making it all fit and organized, and you'll see that even after all the components are screwed to the panel and I think I have it right, I continued to make edits once the panel is hung on the wall and I've started running wires. Like I said earlier, these blue boxes are called the Serbo and its extender, which are made by Victron. These components are the main hubs that will monitor batteries, control charging, and activate any relays installed, among other features. This is a very fun future project.
All right, so it's time to install this thing. I've got all my channels cut out and a bunch of these zip tie holders glued in place. These are the things that Mike 3D printed for me, and they're glued on with the MMA glue. But yeah, I'm ready to install this thing. Cool, so now I get to wire this thing in.
These fuse blocks and all the components that we are installing are made by Aegis Mobile. They are downstream distributors from the main distribution that I just installed. Here I'll be dividing up more broad circuits like lights into individual circuits. The navigation electronics, navigation lights, fans, USB outlets, basically any circuit in the boat that will have multiple loads on the same breaker. I have to break them up with fuse blocks because every wire has to be protected by a fuse that prevents overcurrent from a shorted circuit, which can lead to fires on board. Otherwise, I'd have to have a breaker switch on the panel for every single light and outlet, and my breaker panel would have roughly 1 million switches, which I just don't have room for. So in the end, these fuse blocks save time, money, and space. You'll also see that I'm installing a couple more of my remote light dimmers here for the overhead lights in the doghouse and for the courtesy lights. This is the fuse block for the USB outlets. Aegis makes fuse blocks in all shapes and sizes that will fit a ton of applications. This work is really tedious, but so satisfying to see it come together and look nice. Of course, everything is labeled so I know where it goes and what it's controlling.
Finally, all of my cables that are running to everywhere throughout the boat have been organized into this cabinet. So the next step in here is to get the switch panel in place, and the switches can now run to all these terminal blocks, which will in turn power every different circuit, the 24-volt circuits in the boat. So this was a real tough practice in organization. I think it came out really, really well. It took like, I don't know, 5 or 6 days to get this whole thing done. I gotta say big thanks to Aegis again for supplying our bus bars and terminal blocks and more of these fuse blocks that I installed. I think it all looks really great, and yeah, I'm very excited for like I said, the switch panel to come in. We are finalizing that design. It will be here, I hope, within the next month, and we'll get that thing built. It will be on a door that will open, and then we can access the backside of that switch panel this way. So yeah, very happy with how this turned out. Thanks for watching.